All right, so I've loaded up my sketch here on my mobile device. I'm screencasting so you all can see it. Let's go ahead and play. And so far so good, but if I try to do a swipe, yep, looks like I'm getting that same error. Okay, so that's actually some helpful information because, let's get rid of this here. Then we know it's something in the code and not something, conflict with mouse versus touch input, for example. So looks like this error is happening. So I can see it's in sketch.js on line 37. So what I'm wondering is maybe that touch ended event function is firing after the touch has already ended and there's nothing in the touches array anymore. So that might be why it is complaining that we're trying to call that information out. So let's go back to the reference. And let's go back to events. Let's take a look at touch ended. So it doesn't really explicitly say, but from the way that this sketch is behaving, I'm just going to kind of assume that by the time this event function is called, we don't have access to this touches array anymore. Luckily, I think what we can do is bring in the touch moved. Add that as an event function, and then basically just keep recording the last point that was touched into this touch end variable. So I'm just going to cut and paste that into my touch moved event function. And then when the touch ends, we can calculate the vector between the starting point and the ending point. So let's get our screencast back up. Make sure I do a refresh here. Okay, all right. So that looked like it actually worked. So that's the behavior that I was kind of anticipating. Now, what I noticed is that, as soon as I moved my finger over the screen, the big orange brain just went away. So I need to do some additional tweaking to that vector so that I don't apply so much velocity to that sprite. And so for that, let's take a look back again in the P5 reference. Let's look at our math section, and let's look at our vector object. So again, a vector, it's a mathematical way of describing a direction and a magnitude. You could also think of it as almost like a line where it has a direction and a length, and that's kind of corresponds to the magnitude. So right now what's happening is we're creating a vector between the starting touch point and the ending touch point, and we're applying the direction as well as the length of the distance between those 2 points to our big orange brain. And so what I want to do here is I want to keep the direction, but I want to tamp down the magnitude. So let's go scroll down here in the P5 reference. And so we might have some good luck with multiply. So basically we could scale down the vector. I think I want to try to find one. Yeah, I think normalize might be better. So basically, this is going to preserve the direction, but it's going to take the magnitude of the length down quite a bit. So let's go ahead and see how this works. So v.normalize, where v would be our vector. And we can call it on this touch ended, so we can just say player vec normalize. Got it, and looks like we're going to have to test this on our phone. Luckily, I'm still casting here. So let's refresh. Hey, there we go. Great, so that's working. What I'd like is to make some adjustments because it looks like basically that brain is floating, and basically, we're sort of pushing it, we're adding some velocity to it. So pushing it in a direction, but I'd like it to behave almost as if it has more friction, I guess. So that's going to be something that's happening in the P5 play library. So we could maybe play with something like limit speed. Well, I could see I have an add speed method. So we could maybe add a negative amount of speed so that over time the motion will decay and it will slow down and quit sliding around the screen. And I noticed that I would need a rotation angle, so I'm wondering if under the properties, if we can just call out whatever the rotation of the sprite happens to be. I see we have get direction. So I think the approach I want to take here is to access the velocity property of that sprite and set up some logic in my draw loop so that it decreases over time. And let's go ahead back to sketch here. So on this line 27, we're going to be applying the velocity that's made by the swipe across the screen. On the next line, I want to use that velocity property, and we'll just multiply it by something like 0.9. So basically, every frame, the velocity will be slowing down by 10%. And that's probably going to be a pretty substantial drop in velocity. So let's go ahead and save this. Let's get my screencast back up. And while I'm at it here, I want to switch to present mode so I can see this more easily. And maybe we're taking that down too aggressively. So that doesn't seem to be working. Rather than directly accessing that property, let's see if we can do this set velocity. Okay, so this makes more sense. I want to use the set speed because this allows us to specify a speed, and if we don't specify an angle, the object or the sprite will just keep going along its current direction. So let's try that instead. Okay. Yeah, I wasn't quite sure how this speed scaling factor would work, whether we could just say apply that to whatever the current speed is. In this case, it looks like we need to also reference the current speed, drop that down a little bit. So let's see if we have a get speed method. Here we go, get speed. So again, if we are typing in just a static number there, it is going to set the velocity to that number, and it's going to move in its original direction. By adding in this get speed method, we're going to say take whatever the current speed is and drop it down by 10%. Okay, so let's refresh. Cool, that's looking better. So I do see it starting to decay. Let's go ahead and I want this to be decaying even faster. But in general, that is the behavior that I'm looking for. At this point, I just want to spend some time kind of tweaking how quickly I'd like that speed to decrease. So that's maybe a little too much. Let's split the difference, 0.25. Make sure I refresh. Make sure that I save. Cool, that's looking pretty good. So getting some more of the basic functionality that I want here. I may do some additional tweaks to say, once it reaches a certain slow speed, just set it to 0 so that it's not sort of gently floating off the screen like that. But really that just seems to be a matter of adjusting this number. So in the next video, we'll take a look at setting up some collisions between our sprite objects and see if we can get some more interesting interaction that way.